Okay, so now what we're going to do is we're going to start graphing cosecant and secant. The best way to do this is to use sine and cosine to help you out. Okay, so we need to remember that cosecant is equal to 1 over sine. And we need to also remember that secant is 1 over cosine. Now, since we are dividing, we need to recall that the one number that we cannot divide by is 0. So whenever sine of x is equal to 0, the graph of cosecant will have a vertical asymptote. Okay, the same thing is true with secant. So whenever cosine of x is 0, the graph of secant will have a vertical asymptote. So you really, really do want to use the graphs of sine and cosine as a guide, so you don't, have to kind of think about, memorizing where the asymptotes are. So if you memorize or get familiar with sine and cosine, what's going to happen is you will automatically be aware of where those vertical asymptotes will be. Okay, so we're going to do a basic parent graph for secant and cosecant. Okay. So we'll start with cosecant. I'm going to do 2 cycles. All right, here we go. So again, we're just going to graph normal sine. And usually what I do is I dash it out. So I can see what's going on. Okay. You can use any color that you wish. I'm going to use kind of an orangey color or a yellow color. Okay. So let's start with that. So let's start with sine. Okay. So we're going to go up. Now, again, all of these things can be graphed on Desmos, but Desmos is not going to graph out the asymptotes. You can actually see them. Okay, so let's do the asymptotes now. So I'm going to choose another color. Let's go red. Okay, so wherever I see a 0, I'm going to have an asymptote. So I have a 0 at -2 pi. I have a 0 at -pi. I have a 0 at 0. I have a 0 at pi. And I have a 0 at 2 pi. Now what happens is when you flip these guys over, if you flip over a 1, it doesn't really change. But if you flip over this guy, what it literally happens is it goes like this. Okay, and this one will turn down. Okay, and we can do a table of values so you can actually see how the values change. But that's the basic graph. Okay. All right. So that's my Cosecant graph. Notice I use sine as a guide. Okay, so now what we're going to do is we're going to do the same thing for secant and see what that looks like. So I'm going to need secant. Now remember, secant is the reciprocal of cosine. Okay. And if you think about the graph that we just did, you will notice that those asymptotes happen at regular intervals. And again, I'm just going to do 2 cycles so I get a really good feel of what things look like. All right, here we go. So again, we're going to start with a yellow kind of color for the graph. So again, we're starting with cosine. Okay, so cool. Remember, cosine starts at 1. We're just following the values that we've seen on the unit circle. Okay, now we get to put in our asymptotes where we see that 0 happening. So I see 0 happenings on the halves. So I put asymptotes there, just kind of dash them out. Okay, here we go. Let's graph. So now remember that these graphs do continue, so I'm kind of stopping that just so we can fit everything we need. Okay. So the better you are at graphing sine and cosine, the easier cosecant and secant will be. Okay, so let's do something with an amplitude and maybe a period change first, and then maybe in the next video we'll do a phase shift and a vertical shift. Okay, but let's keep it simple. Let's just change the period and change the amp. Oops, I forgot one. Okay, so we'll do a weird one. Slightly weird, not too weird. Okay. All right, so I have an amplitude of 5 and a period of 1/2. Okay, notice the pi went away, but that's okay. It's all good. All right, here we go. Okay, so actually got to count out 5 on this one. All right, here we go. We're just going to change the period. So the 4th tick mark, that's 1 cycle. So that's 1/2, 1/4, 1/8, 3/8. No pi because it cancels out. Okay, now since this is cosecant, we're going to start by graphing sine. Okay. I'm just going to use my yellow color just to get that dashed graph to help me out. Okay, these should be curved. They shouldn't be points. Again, where you're going to see your zeros, that's where your asymptote should be. Now, if you want to play around with Desmos and graph like original ones and changed ones so you can actually see the effect of the transformation on the graph, like I shrunk this, but you really can't tell because I am freehanding it. Okay, and now let's do our graph. And that is it. Okay, not too bad. All right, let's see if we can do one with a phase shift. Okay. So let's do a fairly simple one. Let's do secant x minus pi over 2. Okay, so no amplitude change, no period change, just a phase shift. Now, if you're able to graph sine with a phase shift just right off the bat, feel free to go ahead and do it. So this has a phase shift of right pi over 2. Okay, let's go see what that looks like. Okay, again, this is secant, so we're going to want to use cosine. All right. No period change, so everything stays the same. I always found these graphs to be kind of fun, but again, you guys should know by now that I am a little strange like that. Oops, forgot my negative. Now, again, if you're able to graph it with a phase shift, with no, you know, okay, it's up to you. Okay, but I'm going to go ahead and graph the original, and then I'm going to phase shift it. So secant, secant is cosine. It's very easy to get the two confused. Now I could just continue on, but I'll just stop. Whoops, too high. Okay, so this is cosine without the phase shift. Let's do one with the phase shift. So if I phase shift right pi over 2, that shoves everybody over 1 tick mark. Okay, now I want you to notice something before we move on, that if you look at my cosine graph and then if you look at the shift, doesn't it look just like sine now? Huh, that's interesting. That might come up in second semester. Little drop hint there for those of you watching the YouTube videos. All right, here we go. So let's find our zeros. Oops. Zeros get asymptotes. Oh, wow. Look, if I shove cosecant over pi over 2, I get... Whoops. If I shove secant over pi over 2, I get cosecant. Interesting. Isn't that kind of cool? That's kind of cool. But again, you guys know that I'm a little weird. All right, here we go. Let's do our graph. And there we go. It's perfect. All right, here we go. Now let's do one with a vertical shift just to kind of complete the process. And you do know that you can kind of put everything together and make it a big old huge mess, but it is a beautiful mess. All right, let's do one with a vertical shift. Let's do one with a vertical shift and a period change. So let's do that one. No phase shift on this one. So let's see. Now let's talk amp. Okay, secant and cosecant really don't have amps because they continuously go up towards infinity. So we really don't call it an amp, but it is a location of a maximum and a minimum. So that number is still important. Okay. So vertical stretch by 2. Okay, I will not be mad at you if you still call it an amp. Just know that it's technically not an amplitude. Still important because it affects where your maximum and minimum is. Okay, here we go. Last one. And again, you can always use Desmos for this. Okay, but it is kind of good to graph by hand so you get a sense of what is going on. Okay, here we go. So I am going to call that 2, then 3, because I'm going to move up 4, 5, -2, -3, -4. Okay, period. Oops. Oops, I forgot some markings here. Oh, that should be an 8. Fix that. Sorry. Nope. Thank goodness for erasers. Okay, so secant. Secant is the reciprocal of cosine. So we're going to start by graphing cosine with an amplitude of 2 and a period of pi over 2. So cosine. And again, if you're a little bit bored, you can fast forward me. It's okay. All right. Now, what I'm going to do is I'm going to go ahead and put in the asymptotes. Okay, because I know where those are and I don't have a phase shift. So I'm going to go ahead and mark those up. Oops. Because me moving my graph up and down is not going to affect the placement of the asymptotes. So I'm going to go ahead and stick those in. Now, if you're not too sure yet what secant looks like, what I would do is I would vertically shift your cosine graph. So everybody moves up 3. So if you're at 2, you're now at 5. If you're at 0, you're now at 3. You're at -2. You're at 1. Right? So that would be about right there. Okay, 0, you're up 3. I completely messed up my scale, but that's okay. We'll just go with it. If you're at 2, you're now at 5. Anybody catch what I did? Okay. So now my graph looks really weird because I forgot the number 1. Man, your math teacher can't count. Oh, well, gonna be a little off, but that's okay. It's all right. So this is where 1 should be. All right, so now we're all ready to graph. There we go. How embarrassing, I forgot the number 1. But that's essentially what it's going to look like. A little sloppy. It's okay though. All right, so that's basically cosecant and secant. If you know your sine and cosine graphs, you have your secant and your cosecant. Okay? All right.